Well, hello there, my friends. Welcome, welcome, welcome. Are you ready to learn more? Because in this lesson, we're going to create a NumPy array with the array function. Wait, what? Yeah. So what is this NumPy array that we've been talking about this whole time? I want to show you a closer look. NumPy array. It's a data structure in the NumPy library. So you can think of it as a list, a dictionary, or even a tuple, but I want to show you how we can create NumPy arrays. So my friends, we create arrays using fundamental data structures in Python. Now, like I was saying, it could be a list, it could be a tuple, it could be a set. You create arrays using structures. Now, what would be the most famous structure? What do you think that would be? We've already touched on it. We're going to learn how to create NumPy arrays using lists. Wait, we already did that. Well, let me show you what we can do then. If you want to work with a library, you got to first remember that, first of all, we're introducing that library to Python. Yeah, every time it has to be imported. So we'll do that now. Just say import NumPy as NP. See, so now Python will understand that we're talking about NumPy when we say NP. Let's run it. Okay, see how that imports our library. Okay, so you need to get used to that import process because every single time you got to do it. That's all. You get used to it. But I'll show you. For example, we finished our work in this notebook. We closed it. Then when we open it again, this import will go evaporate from the computer's RAM. See, that's why we need to write the imported code line every time, or run it if it already exists. So if we use NumPy without importing it, we will get an error when the code line runs. That's why I just generally import the library with you every time in the lessons, and that way it, makes it a habit. Sure, go ahead. You can leave it out and get the error, and you have to put it in anyway. Okay, so anyway, this method that we'll use to create a NumPy array is the array function. So we can create an array by calling this function from NumPy. Let's implement that. All right, so you are familiar because earlier we were doing the np.array. So I'll define my values in the list. For example, I'll say 2, 4, 6, 8, and let's run that. Okay, so see, we've got the output. We now have a NumPy array. Now, my friends, what did we say when we first met with NumPy arrays? Well, like other data structures, it does not keep the type information of the values in its memory separately. In fact, it just wants to see them all in one generic format and forces a format of the same type. So we call this single format request a fixed type, right? Fixed type is a single format request. That's the theory. Let's make it concrete. So I want to create a list named variable, and I'll say equals, and I'll enter the values in it. For example, we'll say 5.8, 9, and 5. Let's run it. Now let's check the types of the first two elements in the variable. So I'll say print and write type in it. And I'm writing the variable that we just created inside the function. I'm indexing because I want to reach the first element. And I'm opening the square bracket saying 0. Now I'm copying this code and pasting it. And I'm changing the index number for the second element. I made it 1, so let's run it. See, the first element is the float type. The second element is an integer. Now, shortly, each element is kept as a separate type in the background. So we'll create a NumPy array of the same elements in a new variable. Let this be the new variable. I'll say equals and continue. So I'll say np.array and take the list here, put it below, and let's run it. Check it out. I'll call the variable. And see, some of my values are integer and some float when I put them into the array function. But the array function has forced them all to a single type. So when it comes up as the output, it all goes into a float value. Or shows up that way anyway. Now, some of y'all might be saying, wait a minute, why the float value? It's not an integer, but all integers are forced to float type? Well, here's the answer. Float values have a value after the comma. So if we want to convert to an integer, we will lose what's after the point. And there will be a slight deficiency in the main structure. You see that, right? So what's the point? Well, we'll avoid the situation. Doesn't it make sense for Python to have float integer values? So you see, there would be no difference then, right, between 9.0 and 9. However, what will you do if it's necessary to work with integer values due to the project that you're working on? Well, I'll show you. So I've copied it here, and I'll just put it below. For example, let's specify a new variable name. We'll let this be new variable 2. Okay, so see, I'll come to an end here and write 2. And now, just press the Shift-Tab key in the array function. And look at this. The documentation of the array function opens. There are a variety of parameters here. These are all for customizing the array. So if we want to determine the fixed type, we can use the dtype parameter. So just quickly, let's have a look at that. All right, so I'll come in here and just press plus and tab, and yeah, there are explanations of all the parameters here. And let's have a look at what dtype is for. And this is the data type. It's optional and the desired data type for the array. So let's implement that now. So I'll come to the end here, put in a comma, and I'll write dtype. Changed it to int because we want to see it as an integer. Now let's run the code. So check it out. I am writing the variable name. And now they're all integers. So it took its place in our output as 5 for the original 5.8. So we can convert our elements to the data type that we want just by using dtype. But if we leave the job to Python, it will bring us the most optimal one by default. Haha, what do you think of that? All right, so that's creating a NumPy array by collaborating with the array function and the list data structure. All right, I want to see you sticking around. I'll see you in the next lesson.